Introducing Carvana Value Tracker, where you can track your car's value over time and learn what's driving it. It might make you excited.
Whoa, didn't know my car was valued this high.
It might make you nervous.
Uh-oh, market's flooded. My car's value just dipped 2.3%.
It might make you optimistic.
Our low mileage is paying off. Our value's up.
And it might make you realistic.
Car prices haven't gone up in a couple weeks. Maybe it's time to sell.
But it will definitely make you an expert on your car's value. Carvana Value Tracker. Visit Carvana.com to start tracking your car's value today.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again. Thank you for joining us on the Space Nuts podcast. My name is Andrew Dunkley, your host, and joining me, as he does every week without fail because he has no choice, is Professor Fred Watson, Astronomer-at-Large. Hello, Fred.
You're right. I have no choice whatsoever.
Well, your animals demand it. They enjoy their 15 minutes of fame, and it is mandatory.
Yes. Look, I've got a written command to do this every week, but that's all right. It's a lot of fun, and hopefully brightens up somebody's life.
Well, I think so. We get some positive feedback. Yeah. Very few critics, although they are there from time to time, mostly correcting something I might have said, which is surprising in my game. But anyway, we welcome all feedback, of course. Now, today, Fred, we're going to look at the Leaky International Space Station. It's got a bit of an issue at the moment. We'll also be looking at the ice moon of Europa. It looks like there's some activity there involving the pole and something to do with the cracks in the surface, and some listener questions, one about telescopes and atmosphere and whether or not we'd be better off doing our observations from somewhere else. Well, we do with Hubble and the future orbiting telescopes that they're talking about. But, could we establish something somewhere else, perhaps? That's a good thought. And another question from Will in Phoenix about going to Mars via Venus. That's sort of like going to the United States from Australia via Europe, which is the longest way to go. But we'll look into that. But first, Fred, what's happening on the International Space Station? Did somebody, do too much heavy-duty sewing and stick a needle in it and the air's leaking out? What's going on?
Well, that's a great question. As of the present time, as we're recording this, the source of the leak has not yet been found. And I think that the three astronauts on board, whose names are Chris Cassidy, Ivan Wagner and Natalie Ivanishin, two Russians and an American. I think they are all located in a sort of safe module. You remember the International Space Station's got something like 12 individual modules that are all connected by airlocks. The astronauts have been hanging out 24/7, actually, in a module, one of the Russian segment modules, which is called Zvezda. Zvezda is a great word. It means star. And so they're in the star at the moment. I think they may have come out. So the idea was, and let me give you a bit of history. This leak apparently appeared quite a while ago, but within the last few weeks has got significantly worse. It's still not at a level where anybody's panicking, but it does need to be found. Excuse me, with my throaty frog again. It needs to be found. And so the way to do it is to shut the astronauts in a module that you think is in good shape and nothing happening there, and then sort of pressurize each of the other modules in turn to look at the one that has the leak rate that you're looking for. And as far as I know, that has not yet been found. This is one of these things that moves very quickly. By the time this podcast goes to air, it may well have been found, and the panic might be over. But
is this the same leak that we talked about some time ago? Because they've had this happen before, haven't they?
And it's really interesting you should mention that, because that is also, in a sense, in the news. You might remember that a leak, this is 2 years ago, actually, exactly 2 years ago, Andrew, a leak was discovered in the service module of one of the Soyuz return spacecraft. So this is a module that is used for habitation while it's on the space station. It's pressurized, but actually burns up in the atmosphere. It doesn't make it to the ground. It's one of the disposable modules. But you might remember that a 2mm hole was found in it with marks made by a drill from the inside. So that hole was drilled from the inside.
It was a big mystery.
Well, it remains a mystery. Let me see if I can find the press release about this, because it's really interesting. The Russian space agency, Roscosmos, basically put in a major investigation about this to find out when it happened. Did it happen on the ground? Was it a mistake? Was it intentional? Was it somebody on the space station itself who drilled a hole because they wanted to get home quickly or something like that, because they were going stir crazy in the space station? Those were all questions that were raised. And there has been a development which actually took place late last year. Apparently Roscosmos now knows what happened, but they're not telling anybody.
Oh, really?
That's based on comments by the head of Roscosmos, the head of the Russian space agency, whose name is Dmitry Rogozin. He was talking at a youth science conference, and he's quoted as saying, "The hole was in the living quarters of the capsule. It has long since burned up on re-entry. We took all the samples. We know exactly what happened, but we won't tell you anything. We do need to retain some sort of secrecy." And apparently people think that was a tongue-in-cheek thing, but NASA doesn't know what happened. So the Russian Space Agency clearly has done an investigation, found out what it was, but nobody knows.
I'm busting to find out now.
Yeah, well, I think everybody is. Apparently,
fascinating and a little bit creepy all at the same time.
Yeah, this press release says something is along the lines, Roscosmos, sorry, I'm reading from a press release here, which I should quote, comes from Science Alert. Roscosmos continued to conduct its investigation, and the news agency reported that it was a mistake made during manufacturing, which Rogozin, the head of Roscosmos, swiftly denied. And what caused the hole is yet to be officially revealed. Whether or not Rogotzin's remarks were tongue-in-cheek, the results of the investigation have yet to be communicated. Now, remember, this is last September, so that might have happened, but have yet to be communicated with NASA. According to the US agency's administrator, Jim Bridenstine, they have not told me anything, he said. I don't want to let one item set the relationship back, but it's clearly not acceptable that there are holes in the International Space Station. And he said he would also speak with Dmitry Rogozin, and that might have happened. They might have sorted it all out. But that's
Well, maybe Roscosmos is remaining silent because they're negotiating a deal on movie rights.
Could be, that's right. Anyway,
they're trying to get money from all and sundry. I guess a movie would probably rake it in.
Who drilled the hole in the space station? Or it's not even.
Yeah, that's a good title. But that's got nothing to do with what's happening at the moment.
No, that's right. Because that hole disappeared as that capsule burned up. But as far as I am aware from everything I've read, the present hole is thought to be in one of the main modules of the space station. Now, the space station leaks all the time, apparently. It would be absolutely impossible to make something that big, absolutely airtight against the vacuum of space. I've worked in vacuum technology, and no matter, just as soon as you turn your back, you've got a leak somewhere. It happens all the time. So it's I think a masterful accomplishment that they've managed to keep it as airtight as they do. So it is constantly being replenished, but they clearly monitor the leak rate, and at the moment it is at a level that's not considered acceptable, even though it's not dangerous. It's well within safety considerations, but not acceptable.
Well, maybe they should do what they did in Mission to Mars and just squeeze out some Dr. Pepper, and it'll just suck its way through the void, and voila, they'll find the hole.
Yeah, maybe that's right. I mean, it's like you probably remember how you find a hole in a tire in a tube. You put it in water and look for the bubbles. Unfortunately, you can't do anything like that. So it's a difficult problem, but anyway, one that we will keep the Space Nuts audience up to date on.
How far does it have to go before it becomes a critical situation? If they're in a safety zone now, that suggests there are concerns.
Yeah. The concern is, you don't want it to get worse. So we'll see.
And yet that's what's happened. It has actually worsened.
Yes, that's right. I think some weeks ago it got worse, and that's why this procedure is taking place.
So it just makes me think of more and more questions, Fred. But if they're sort of sitting in, as you called it, the star for safety reasons, do they never come out, or do they pop out occasionally to, cook a roast? What do they do?
I don't know the answer to that. As far as I know, they're sealed in there. They've certainly spent more time in there than they expected. It was going to be just this week, last weekend.
Good grief!
Yeah.
All right. It's a very, very difficult situation because they're the only ones that can really investigate it, aren't they? Unless you send another team up there, which is very expensive to do. But we're talking human lives here, so you can't just say, "Oh no, she'll be right, mate." Although that's what Australians would.
Much of the investigation will be done from the ground. You can't go.
So they've got the telemetry to actually.
I think that's right. Yeah.
Keep an eye on this.
Yeah.
Ah, interesting. All right. Well, hopefully soon we'll find out what it is, why it happened, and hopefully they can fix it with a bit of chewing gum or something, and all will be okay.
They used epoxy and sticky tape the last time, so that's probably what they do this time too.
Yeah. Well,
this one's got.
That reminds me of a radio.
Yeah. Sorry, I was going to say.
Sorry, go on.
It's got to be more permanent because that last one was in a module that was going to burn upon re-entry anyway.
Yes, of course. Yeah, this is in a main area. But it reminds me of a radio station I worked for. Once I was looking at the control panel and the technician came out. He said, it's a wonder of science, that. I said, why? He said, most of it's held together with chicken wire. I said, what? He said, yeah, the radio station's wired with chook fencing. I said, you're kidding. He said, the best stuff. Yeah. The best stuff. It does the job. And I'm looking at this and I thought, oh, my goodness. Anyway, we stayed on air until a council motor mower went through our cable, which had never been buried, and knocked us off air for 2 weeks because the part was in America.
Oh, there you go.
It blew up the transmitter. But that's a very different problem to the one they have on the International Space Station. So hopefully in the not-too-distant future, we will have positive news on that scenario. You're listening to Space Nuts with Andrew Dunkley and, of course, Professor Fred Watson.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Once again, I'd like to shout out to all our supporters that use social media to get in touch with us, whether you're listening via our YouTube channel and listening non-stop. You can press play and listen to all episodes without taking a breath. I'd like to see you try that, actually. They're trying it on the International Space Station, in fact. We also would like to thank our Space Nuts podcast group, because that's a group where everybody gets together and talks to each other and asks each other questions. There's some ripper questions going around lately. So it's a good place to be if you're a Space Nuts fan, so you can meet other Space Nuts fans. Of course, we've got an official Facebook page as well, and you can find us on most social media platforms if you have a favourite, Instagram, Twitter, etc. So thanks for supporting us on the social media platforms where we make our presence felt. Now, Fred, we're going to look at the icy moon of Jupiter known as Europa. This is one that they've certainly looked at as a potential place for searching for life. It's also well known for its incredible cracks and amazing surface. But now it's in the news for a completely different reason. What's going on now?
It's analysis of the cracks and fractures which have been recorded by various spacecraft, including Galileo and Voyager, This is work that has been done actually at the Lunar and Planetary Institute. So it's effectively come from a reanalysis of these old images, because we now have, such wonderful image processing software that you can actually tease out details that weren't obvious. So the cracks in the surface, and they are really quite extraordinary when you see them close up. They've got real structure to them. Some are cracks, and some are sort of double ridges. But these scientists at the Lunar and Planetary Institute have examined them in detail and discovered something quite dramatic, which confirms, first of all, what it does is confirms the picture we have of Europa, which is of a rocky object overlain with a global ocean of water, over the top of which is a layer of ice, a common structure that out there in the outer solar system that you and I have talked about a lot. But what that means is that the surface that you see is kind of decoupled from the body itself, because the majority of the mass of Europa is in the rocky core of it. The overlying ocean and the ice over that is a relatively small proportion of its mass. And so the surface can sort of wander around independent of the body itself. Now, we see that clearly on Titan. If you're on Titan, there is a wander of the surface relative to the core of Titan, which means that your longitude changes, which is not something that happens on Earth. When you're at a given longitude, you're there for good, unless you move, of course. But on Titan, you can stay still, but your longitude still changes because of the fact that the surface kind of wanders backwards and forwards slightly as it orbits Saturn. So
that would make satellite navigation a lot of fun. Yeah,
that's right. It just adds a whole new dimension when the surface that you're on isn't really representative of the whole of the object that you're talking about. So so the surface of Europa floats on the ocean, and what these scientists have done is basically done a statistical analysis on all these cracks. And they can find sort of global scale circular patterns, which probably formed when that icy shell, the icy surface that we see, has actually been reorientated. It's a process. It has a name. It's called true polar wander. And it means, the pole has wandered on the surface. Actually, it's the other way around. It's the surface that's wandered with respect to the pole. So the evidence is very strong that within the last, and this is quite recent, of course, within the last few million years, the icy surface of Europa has tipped over by about 70 degrees. That's a colossal amount. It's nearly a right.
That is huge.
Yeah. But of course, that is, again, it's further evidence for the fact that the ice surface is floating free from the rocky core. And so it's a really remarkable result and confirms what we think the structure of Europa is. Remember, Europa has also shown signs, measured, I think, by the Hubble Space Telescope, of having ice geysers near its south pole, just like Enceladus, the moon of Saturn, but not quite as prolific as the ones on Saturn's moon.
I mean, we do see something similar on Earth because our poles move and they have to recalibrate where they are every 12 months or so. And I think you and I talked about the fact that the North Pole had moved a fairly dramatic amount over a short period of time, but it's not for the same reason, is it? It's a very different circle.
That's the magnetic pole, Andrew. It's not.
Yes, that's right.
Not the rotation pole. So the Earth's rotation pole does wander around, but only over distances of a few meters, 10 meters at the most. So standing on the North Pole or the South Pole, you at any given time, you probably couldn't say within a few centimeters exactly where the pole was because it wanders around. You're quite right, though. The magnetic poles actually have much bigger excursions. And the North Magnetic Pole is currently zooming across past Siberia, if I remember rightly, as you and I have spoken about. So this is the real pole, the rotational pole. And the reason why it happens on Earth is because of all the stuff sloshing around in our molten core. It's a different phenomenon from what we're talking about here on Europa. The reason why it's happened on Europa is because it's got a solid core, but on the top of it is this thing that just floats around. And in some ways, it's amazing that it doesn't do this kind of thing more often. You might imagine that if the surface is decoupled from the center, the surface could do whatever it likes. But there is clearly some stability in there that keeps it reasonably aligned over long periods. Remarkable.
Would that be gravity or something that's holding it in place? It sounds like it's not continuously sliding around on itself, so it has periods of non-movement.
Yeah, so
but over time, it sounds like it's really swung around a few times.
It is to do with gravity, and it's all. I guess it's, if you think of it as being like a flywheel, the core is rotating. It's coupled by the ocean to the surface. The ocean is fluid, but it's still got some friction to it. So the surface wants to follow the rotation of the core. But maybe from time to time there are events that happen, and there will be gravitational events, I'm sure, which cause that coupling to be less strong, and you get the surface falling over by 70 degrees. Remarkable story.
Quite incredible. I suppose the power of the gravitational effect from Jupiter would have something to do with it, perhaps.
Exactly, that's right, because Europa's pretty near Jupiter, that's right. So there's a tidal effect there. Maybe, there is a mission planned called Europa Clipper. That's one in prospect for some years down the track. I think it's actually, it will get there before the end of the decade, and that will, because it's an orbiting spacecraft, Europa Clipper will send us highly detailed maps of these cracks and ridges, and we might know a lot more about what's happened on Europa after we've seen them. So it's something to look forward to.
Absolutely, yeah, fascinating place, and of course the prospect of potential life forms in its oceans, always an exciting prospect.
That's right.
Okay. You're listening to the Space Nuts podcast with Andrew Dunkley and Fred Watson.
3, 2, 1.
Space Nuts.
As always, I'd like to say thank you to our patrons, the people who financially support this podcast through their own generosity and off their own bat. It's not a necessity, but if it's something you're interested in investigating, you can do it through several platforms. Now we have an account through patreon.com, so patreon.com/spacenuts, where you can sign up for as little as $3 a month. You can also do that through Supercast, and we've got package deals on Supercast, and you can do the first 30 days without having to pay a cent. You can also do it through our Acast platform. That's our major platform for distribution of the podcast. They have a donation service there as well. You can find all the details on our website, spacenutspodcast.com. But thank you to our patrons. And as a patron, of course, you get an early edition of the release of every episode, commercial free. And we often add bonus material so that you can have that as well. And if patrons ask us questions, we answer those exclusively. So all sorts of good reasons to become a patron. But as I said, it's voluntary. You don't have to do it. We are not going to force you. But thanks to those who have already joined the long-growing list of patrons. Now, Fred, it is question time, and we've got a couple of audio questions today. This first one is from somebody unidentified, but we've kind of figured out they're Australian, so we're going to call him Aussie. And here is his question.
Hi, guys. My question is about telescopes and the atmosphere. In that, has a measurement been developed for how good the image is through an atmosphere? would it be better on another surface, say the moon or a planet or another moon of another planet? Has measurements been done anywhere else other than the Earth? So sort of when we get to Mars or things like that, would we be able to make better use of telescopes on those in those places? Great show. Keep up the good work. Long time listener. Thanks, guys.
Thank you. We're going to call you Aussie, but thank you for the question. And he brings up an interesting point, and you and I have discussed before, Fred, the issues of, the atmosphere making certain observations difficult from the surface of the planet. But some of that was overcome with the Hubble Space Telescope, and will also be overcome even more by the James Webb Telescope. But what about setting up telescopes on the Moon or on Mars or something like that? Would there be advantages in that in the future?
It will happen, yeah. There are already telescopes on the Moon. The Chinese... Now, which one was it? I've forgotten the name of it, but it had the U-21 rover. I've forgotten the name of the spacecraft itself. U-21, was it Tiangong? Can't remember. Anyway, that had an ultraviolet telescope on it that was looking at stars from the surface of the Moon and making measurements. Very interesting stuff. What interested me about this question, though, was the first sentence about whether a measurement has been developed for how good the image is through an atmosphere, and it has. And it's been there for about 200 years, 300 years maybe. Astronomers. Certainly in optical and infrared astronomy, visible light and infrared astronomy, they have a parameter which is called the seeing. And the seeing is basically a measurement of the diameter of a star image, which should be a point of light. But when it comes down through the atmosphere, it's blurred out. In fact, it turns into when you look in real detail at the image of a star through the atmosphere, it's this kind of wobbling football. It's in constant motion because of the atmosphere itself being in movement, and it's sometimes it's blown up in size. So at Siding Spring Observatory, which is certainly one of the best sites in Australia, a mountaintop site. Not very far from where you live, Andrew.
You took me up there one day, and it was bitterly cold. It was so cold up there. That tends to be what happens on mountains. Anyway, the seeing is typically 1 to 1.5 arc seconds. That's reasonably good seeing. So an arc second is 1/3600th of a degree, the size of a dime or a dollar coin at 5 kilometers. It's a tiny angle, but it should be less than that. If there was no atmosphere, it would be simply a point of light. So 1 to 1.5 arc seconds is reasonable seeing. In bad weather, it can blow up to 10 arc seconds, and what that means is your light is so diluted that you hardly see anything. However, on the best observing sites in the world, it's much less than that. In Chile, they get seeing down to 1/3 of an arc second, much better than we get because the atmospheric conditions are better. So that is the measurement. There is another one that's related to that, and it tells us a little bit more about the structure of the atmosphere. It's something that we call R0, and R0 is the characteristic size of a cell of warmer or cooler air. It's a measurement, and it's usually measured, it's of the order of a meter, something like that. On a site with very good seeing, it might be much more than a meter. But for somewhere like Siding Spring, it's probably less than a meter. It's the size of a blob of air that's going past a warmer or cooler air that's going past the telescope. And the reason why that's important is that we now have the ability to correct for that with this technique called adaptive optics. So you can sense
actually using lasers usually, but you can sense the passage of these blobs of air across the mirror of the telescope, usually at all kinds of altitudes, low altitudes, high altitudes, the whole thing. You can check what that movement is and then correct for it. You can essentially take out the distortion in much the same way as noise-cancelling headphones take out the extraneous noise around you. It's a cancelling technique, and it's now really reached a stage of perfection that's taken 20 or 30 years to get there, but it's enough that it makes it worthwhile building huge ground-based telescopes on the Earth. So we've got the Giant Magellan Telescope coming up, 23-meter effectively. We've got the TMT, the 30-meter telescope coming up. And we've got the ELT, the European Extremely Large Telescope, which will have a mirror 39 meters in diameter. That will far outstrip the Hubble in terms of the detail it will see because of this adaptive optics technique. So we've figured out how to essentially eliminate the deleterious effects of the atmosphere. That's the blurring effect. There is one effect that you can't get rid of, though, and that is that the atmosphere absorbs certain wavelengths, in particular in the ultraviolet, and that's been one of the great strengths of the Hubble telescope. It's above the atmosphere, so it's very sensitive to the ultraviolet region of the spectrum. And you can't deal with that on the ground. You've got to go into space for that. And maybe the moon, maybe Mars. It's probably cheaper to put something in orbit around the Earth or in orbit around the Sun, which is what we've been doing. But eventually, when humans are walking on Mars and walking on the Moon, we probably will have telescopes there too.
So I suppose when we do ultimately, have telescopes, maybe on the Moon, maybe on Mars, if they do go that way, will it make much difference to our perspective as we see things from Earth, given the scope and size of the universe? Would it be minuscule variation?
Yes. Sitting on Mars is the same as sitting on the Earth as far as the universe is concerned, because even you're not even far enough really to see a difference in the positions of the nearby stars. There's been one example, though. It's a great question, Andrew. About 2 months ago, the New Horizons spacecraft observed a star which was simultaneously observed from Earth. And the baseline of those two observations, because New Horizons is now, I can't remember how far, it's 7 or 8 billion kilometers away. So there you've got a huge baseline for what we call a parallax measurement, the idea that you're looking from one position and another to see how a nearby star changes relative to its background. And so some of there was both the southern hemisphere star and a northern hemisphere observed with those observations. It was remarkable. You could see the difference because the spacecraft is so far away from Earth.
Interesting. Very good. And Ozzy, thanks for the question. The short answer is yes. We could have just done that, I suppose, but wouldn't have been nearly as interesting, but appreciate the question. Thanks for throwing it up. Now, let's move on to our next question from Will in Phoenix.
Hello, Andrew. Hello, Fred. My name is Will. I'm in Phoenix, Arizona in the United States. I saw an article recently that was talking about the travel time from Earth to Mars, and they were saying in the article that it is possible to get to Mars faster if you swing by Venus first, and then on your way back home from Mars, you swing back by Venus. I've been playing a lot of Kerbal Space Program, which is like an orbital mechanics simulator, and I don't quite understand how that would work. And I would love if you guys could try to explain to me how going into the inner solar system more gets you to the outer part of the solar system faster. Anyway, love the show. Thank you very much.
Okay, well, thank you, and I hope all is well in Phoenix, Arizona. I've actually stepped on Phoenix soil very, very briefly in my various trips.
I've spent a week there.
Yeah, I was there I think I was in Phoenix for a couple of days at the most. Now, it's an interesting question. Is it quicker to get to Mars via Venus? We've got 3 missions going to Mars at the moment. I'm assuming none of them are going via Venus, or are they, Fred?
No.
They did a slingshot around Earth to get some speed up and get out. How would this work?
So I don't know the answer directly, but I'm pretty sure that Will is right. It is very unlikely that going in to swing by Venus and then get to Mars would get you there faster. It kind of intuitively, you can imagine it being possible, but you'd never use it because when you're going to Mars, as you and I have spoken about before, Andrew, there are only certain times when you can make the journey, when Mars and the Earth are in the right relative position. And now is one of them, which is why we've just sent off 3 spacecraft to Mars within the last month or so. If you were having to swing by Venus as well, you've got to wait. You don't just have to wait until Mars is in the right position relative to Earth. You've got to wait until both Mars and Venus are in the right position too. And that could mean you're waiting for years because you've just, you don't have that opportunity. It's every 2 years or so that we can go directly to Mars. So maybe it's possible. Maybe you could do it faster, but you wouldn't want to do it because of all the delays. It's great to hear that Will's been playing with the Kerbal Space Program. My son, also called Will, used to play with that a few years ago, and I was always really impressed with how that works. It's as Will says, it's an orbital mechanics simulator. You can build your own rockets, but it all works according to the laws of gravity. So it's a great way to learn about space navigation, and a very effective tool. I'd recommend any techie-minded youngster who's interested in space exploration actually has a look with the Kerbal Space Program because it works very well. So if Will's not managed, and this is our listener Will rather than my son Will, if he hasn't managed to recreate a slingshot from Venus to get to Mars, it's probably not possible. It's a really interesting question, though. It is counterintuitive to go into the inner solar system to build up speed to get to the outer solar system. But thinking about it, it might just be possible that you could shave a short amount off the time. But as I said, the killer would be having to wait until everything's in the right relative position. I think that makes it a complete non-starter. Yeah, Will's right.
And as you and I have discussed with the mission to Mercury, going towards the sun is actually a much more complicated process than going away from it. And that kind of makes me think trying to do a slingshot around Venus to get to Mars is probably not that simple.
No, it's not. That sort of thing's been done. I think Cassini had slingshots around Venus on its way to Saturn. I think that is right. I might be wrong there. I'm dredging up from a memory of several years ago, but it can be done. You can use the inner planets to slingshot you to the outer planets. But once again, everything's got to be in the right place. You've got to have the alignments set up for you by nature, which is not something you can sometimes wait for. So probably in the last analysis, most of our future journeys to Mars, as all the past journeys have been, will be the direct ones. Simple Hohmann transfer ellipse to give it its name.
Yes. Now, Fred, I am willing to stand corrected on this, but late these last few nights, I've looked out over a little hill to the east of Dubbo, which is the only hill we've got, and I've noticed a red spot above it. Is that Mars?
What time have you been seeing that?
Around 10 p.m., 9:30, 10.
I think it's Mars. I think it's probably right.
Yes, I thought it was. It's just a very distinct red, and we've reached that that annual event, the spoof email that's telling everybody that Mars is as big as the moon in the night sky. It's an absolute scam. But It's been going for about a decade. That one, possibly longer.
More. I think it was, if I remember rightly, it was 2003 when that close approach took place. So yes. A hoary old one is that.
Yeah. So if you receive an email saying that that Mars is going to be in the sky as big as the moon, it's a trick. I mean, it's a very clean joke. There's no one will get hurt, or their bank accounts won't be emptied. But it's a spoof email that's been going around for probably 17 years now, and it's still circulating.
Yeah, it's every 27th of August, I think, if I remember rightly, which was when the opposition took place.
Yeah. It's funny. And anyway, Will, thank you so much for your question. Really appreciate it. Interesting, very interesting indeed. And Fred, that brings us to the end of yet another episode of the Space Nuts podcast. Thank you, my friend.
Thank you, Andrew, too. And let's keep up the good work, and we'll speak again soon.
We will indeed. Fred Watson, Astronomer-at-Large, part of the team here on the Space Nuts podcast. And don't forget, if you would like to ask a question, you can email or message us, or you can go to our website and click on the AMA tab and record your message, as long as you've got a microphone on your device. Just press record, tell us who you are, where you're from, and ask your question. It's simple as that. spacenutspodcast.com, and click on the AMA tab to record a question. While you're there, you can check out Astronomy Daily. You can go to our shop where you can buy all the bits and pieces, T-shirts, polo shirts, coffee mugs, all sorts of memorabilia. And we've even got our bookshop there where all Fred's highly intellectual books are, and my pretty dumb weirdo books there as well. No, that's not fair on my grandfather, because I wrote a book about him, but that one I'll stand by. The rest of them are just for fun. But you can check it all out on the Space Nuts podcast website. And until next time, thank you again. We look forward to your company on a future edition of the Space Nuts podcast.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.